All right, ladies and gentlemen, we are going to be doing 3 days lessons in the next 20 minutes. Okay? The reason why we're doing 3 days lessons in the next 20 minutes is because you've had all this before in 6th grade for sure, and we're going to make the most of it. So, this is multiplying, dividing, adding, and subtracting decimals. I'm going to zip through this, and if there's something that you don't remember or something that is like, what? Then we will go from there. Oops. Now, quiet. Be quiet. Adding and subtracting decimals. The first thing you'd want to do is you want to estimate your answer just so you don't make any silly mistakes when you're done, because it'd be really easy. Did I give you guys one? I'm sorry. Here, it's much easier with this. That would have been a lot of writing. I'm so sorry. I always get this group first, twice, or forget. It's never like the other ones. First you're going to do is estimate your answer. Now, 231 minus 126.7, it's going to be somewhere around 110 maybe-ish, right? Around 110, okay? You're estimating that it's going to be around 110. And that line there, it's a squiggly line over a straight line, and that means estimate. It's about, because equals means that's what it equals. But this sign means it could be that. That's not a good one. There we go. Yeah, it looks like an N. For the N, yeah, tilde. Now we have, here's what we do when we add or subtract decimals. You line up the decimal points. For subtracting, or for subtraction, you have to add zeros as placeholders. So for this top one, it's 231. You're going to put a point 0. Okay? You're going to point 0. You have to put the placeholders in there for adding and subtracting, and you line up the zeros, and you borrow if needed, and you just go back to when you first learned how to subtract when you were in 1st grade. Stop, chill. Hey, chill. Stop shouting out. There's 3 of you that just did. Stop. So I'm just going to subtract like normal. Hmm. 104.3 FM. So we got 104.3. Does it line up to what we said? Yeah, it goes to about what we estimated. Now, if you had the wrong number there with the decimal, then it would be way wrong. If you didn't line them up, for example, it could be a mistake that you could do is you don't have to write this down. This is for demonstrative reasons only. 231, oops. Yeah, why not? 126.7. If you didn't line them up, you would have it all sorts of wrong. You would have a negative something. Okay? So that would be way, way off. Now for addition, remember your integer rules? Actually, I should print that out for you guys. I should print out the integer rules review that we did just in pre-algebra. It is great.
Is it fun?
Maybe to some.
If it isn't math related, I don't want it.
Well, that's way too low. So the integer rules review that we did in pre-algebra, it goes through subtraction, addition of integers, and it goes through multiplication. The multiplication thing was just if the number has negative digits or negative amounts of add-ins or of multipliers or dividends. Okay, that's one that we did there. So I'm going to print that up for you guys and give that to you tomorrow. Good. So with this one, we're just going to use our integer rules, which was we take 12.5 minus 8.3, and if the absolute value of the negative number is bigger, you make that negative. Okay? I lined up the decimals. The main thing about this is line up the decimals, okay? Addition, subtraction, line up the decimals. So to do this as practice, let's do one with a variable. Okay? Let's do one with a variable. I want you to do that as I'm doing it. So if you get stuck, you can look up. Please don't use pen. Look how ridiculous your notes look right now, and your fingers nonetheless. Use a pencil. Please do number 8. The numbers are really weird because I adjusted the pre-algebra notes for this. So please do number 8.
I don't have this one.
Why are you unprepared for class?
No, I have one. I couldn't get it on my backpack.
Then you don't have one. I don't care what you have one at home or in China.
I don't have one in China.
I still don't care. The main thing is you don't have it here with you right now. You don't need to do it out loud. The part that's in the bubble is what was done after knowing the integer rules. So what's the main concept of adding and subtracting decimals?
Line up decimals.
Yep, stack them and line up the decimals. That's correct. Okay, that's what you need to remember for this one. Yes.
That was my biggest issue because I was so used to having to line up the decimals, but in multiplication, usually I have to add a bunch of zeros.
Yep.
And it was just like making the math take longer.
Yep. Yes.
I got -5.9. Yeah. That's what I got.
I did that first, but then I erased it.
Wasn't it? I got 4. Yeah,
Okay. Here's the right answer.
Okay. 0 minus 9 is white.
Oh, I get it.
Because of the integer rules. What you do, and this was last year for you, okay, so I understand why you wouldn't get this, and right now I'm kicking myself for not giving you the integer rules stuff again because the pre-algebra group has had this more recently than you. With the integer rules, what you do is you take the biggest digit, or when it's the signs are different. See how one sign is positive, one sign is negative? Yes, because we have, on this situation here in the middle, we have 3.9 minus 8.0. Do you see that? Okay. I need to go back in time.
Back to the future.
That was yesterday.
It's close enough. I want to make a movie like that just so like in 10 years I can say, oh, geez, Back to the Future 15 day.
Just go make a documentary on turtles.
What?
It should have been.
So here's the integer rules for addition. You have to decide between two addition rules apply. Rule number 1, if you are adding integers with the same signs, as in positive, positive, or negative, negative, you add the digits and keep the sign of both numbers. So if you had negative 13 plus negative 7, you just do 13 plus 7, keep that sign, which is 20. Kept the sign, negative 20. Okay? This is a page that, like I said, I'm going to print out and give it to you guys tomorrow. All right? Whenever we have different signs, as I highlighted here in blue, you're going to keep the sign of the larger digit. So you have 23. You have 23 minus 18. You keep the sign of the bigger digit. 23 minus 18 is 5. the bigger digit is positive, so it's positive 5. Negative 23 plus 18, negative 23, or 23 minus 18 is 5. In this situation, the bigger number is negative, so it becomes a negative 5. If you are doing this homework tonight and you want this page already before tomorrow, you go to this handsome fellow's website, 7th grade, and you will see it. There we go. Right here. Don't say whoa when I do that with my web page. That means you haven't been to my web page because the accelerated is the exact same. Okay. Anyway, if you want those notes, quiet. That's the 3rd time now that after I've said quiet, you said one more. Stop. You click on Integer Rules Review, and there's the page that I was just showing you. Okay? There's the page that I was just showing you. Which one's right? What do you mean right?
Are they both right?
What do you mean?
For the example you chose, 23 plus
Oh, I see what you're saying. Look at the difference here. Oop. See how the 23 is positive on the left side? The 23 is negative on this one. That's just showing you to keep the sign of the bigger digit. Okay? But since people were just amazed, here's your website, 7th grade accelerated. Here's the notes from yesterday. Actually, it's even more than the notes from yesterday. If you guys had questions, that's the wrong page apparently. That's the homework. Okay.
Let's take a look at this, actually.
But here's the stuff that we've done. Like there's the capture from Friday and Monday. Here's the capture from Tuesday. Here's a capture from September 4th. Okay? I'm glad to see that all the time that I take to upload this stuff is being used by so few.
I have watched one of the videos.
You don't have to watch them. That's just for double checking absences, and if parents are like, what is that symbol? Okay?
Yeah, but my dad always has to.
Yep, it's a lot there for parents because it's been so long since they've done it. So long since they've done it.
My mom doesn't understand anything anymore.
So we are going to continue with where we were. We have A minus D. We're going to evaluate 5.3. D is 0.7. And that's how we'd set it up. Okay? 4.5. 4.6? 13.6, yeah. Which would be 4.6. And I'm going to skip the other ones. I just wanted to make sure that we remember. Keep the sign. And I'll keep those integer rules up. All right, multiplying. Multiplying decimals. When you multiply decimals, you should multiply the numbers in the problem first without worrying about decimal points. Okay? So you just line them up and you forget about the decimal points. You can add them in later. After multiplying, you count the numbers that are to the right of the decimal, and you count the spaces in all lines of the problem, not just the top line. So we go like this. When you're doing a problem, you would notice that there are 2 numbers in the right. This one has 1, 2, 3. That's why it's 3. You have 2 plus 3 equals 5 spaces on the right side when you're done. So we will go like this. Well, I should have left a lot more room here. This should be lined up too. I'm going to rewrite that one. When I change the layout. So what's the number? 3.73? Okay, let's try that again. Chris, what is it?
32.03 times 0.074.
So I'm going to do this multiplication. Steven?
Whenever you're multiplying and then whenever you get down to the second row, you're supposed to add it.
Here's how it works to avoid any confusion, especially since there's a couple people that just shouted out and agreed with you. Since I took care of this digit, which was here, that makes this one a 0. What about 2 zeros? Correct. In the third row, when I would have taken care of this one, and I would have taken care of this one as well, this one could have been, and this one would have been zeros. That's all right. It's been a while since you guys have done this. That's a totally reasonable thing. Burke? Oh, by the way, I have your jersey. Did your mom know that? Okay, you left your jersey in Belleville last night. I've got it. Your blue one? Okay, I'll bring it to the game tonight.
What would be the answer?
The answer is being. I want to go here. So as it says, there are two decimals there. There are 3 decimals here. So that means that the answer is going to have 5 decimals. So you go from here, you go 1, 2, 3, 4, 5. And your answer is right there. So your answer is 2.37022. Yeah. Yeah, with this sort of things, you would be able to check your work with the calculator. I repeat, everybody, listen. You are showing your work, but you may check your work with the calculator. I will be making sure you show your work, but you may check it with a calculator. Is that clear? Okay, if you did hear what I said, give me the okay signal. But if you didn't, don't give me a fake okay signal just because I'm doing it. So Aiden, did you? Okay. All right, good.
I just did this on a calculator. It says 23.
You have it rounded. You have it rounding.
I have 23.7022.
Do it again with the decimal places in the right spot.
I did do it.
No, do it again with the decimal places.
So the
Just do it. Now we're going to do, we'll do this one here. We're going to do B. Okay, C. We'll do C. Okay, we'll do C. You guys are loving exponents, so we might as well do that one. So we have evaluate 4 times y cubed, which is going to be 0.6 cubed. I'm going to rewrite that as being 4 times 0.6, 0.6, 0.6. Ew. Let's try it like this. There we go. Oh, so much better. Yep.
This is like what we're gonna have on the test.
Good.
Or I didn't even test anything.
So I'm going to work these out. I'm going to do these 2 first, and then I'm going to do those 2 first. So I'm going to do 4 times 0.6, which is just going to be 32. No, 24. There's 1 decimal point, so there's a nice solution to that one. Then I have 0.6 times 0.6, which is going to be 36. I have 2 decimal points, so it goes doot, doot, to right here. So 2.4 times 3.6. Six times 4 is 24. 6 times 2 is 12. Plus 2 is 4. Put a 0 here. 3 times 4 is 12. 3 times 2 is 6. Plus 1 is 7. I have 1 decimal here. I have 1 decimal here. So now I have 1, 2. So my answer to that one is 8.64. Stacy? Ah, thank you so much. And it won't change my calculations too much, other than that I just need to move my decimal over one more. Thank you. Bert?
Since it's an exponent, shouldn't you multiply all 0.66 times?
When you rewrite it out like this, it's the same. So if I were to do it the other way around, so if I have 0.6 cubed times 0.6 cubed times 4, it's still going to come out to be 0.864 because when I want to put it out in expanded form, yeah, yes.
Do mathematicians know all the irrational numbers?
Do they all know all the irrational numbers? The specific ones like the letter or the number I, the number E, the number pi.
What's the letter?
You'll get to that in high school.
Letters.
Because they can't be represented with a fraction, and rather than saying all the numbers, they just say what they're assigned.
But I looked it up on a website and it said suspected.
Yeah, suspected because they don't know. The name of them. All right. So dividing. There are a couple of major points for dividing, and the major point of this is the divisor must be a whole number. Okay, the divisor must be a whole number. So whatever number you have, you can't put it into a decimal of groups. You have to put it into a whole number of groups. Okay? So what that means is, example 1 is just written out for you. This is the divisor here. The divisor is the one doing the divising. So you have 8.4 divided by 4.2. You cannot have an accurate answer without moving that decimal. So we have the decimal moved from this spot here over to there. We also have to move the spot from being between the 8 and the 4 over to here, and we put the decimal point up on top. Okay? Because that would just be 2. No. I'm going to make it super easy when I'm introducing the rule, so you're not like, why would you have that big of a question? Because that concept applies to all division of symbols. Decimals. Yeah. So here's another example. We have a divisor with a 0.25 and a view that is not big enough. We have 0.25. I need to move this guy over 2, so I'm going to go 1, 1, 2. So I need to go 1, 2 over here as well. Now zeros are going to be put as placeholders because the decimal moved over digits to spots. And I'm going to put my decimal point right there. And that's what happened in the one below it. That's happened in the one below it. And then from there, now I can do my divising. So I have 2 here. 0, 0, 0. So the answer is 20. If I wouldn't have moved that and I would have kept the decimal where it was, I would have 200 divided by 0.25 as being 0.2. And that's not right. Yes, sir?
Will the divisor be bigger than the dividend?
Yeah.
It will?
Mm-hmm. Yep. For example, if we had this. Wait, that's the other way around. Hold on. Here, like that, for example. So I would move this guy over, move this guy over. Here's the new decimal place. Okay? 25 goes into 32 one time. 25. That's going to be 7. 0. Okay, stop talking. This is a valid question, whether he asked if the divisor would ever be bigger than the dividend. So this one here is going to be just barely 2, 50, 20, 25 goes in that 8 times. And that's a really clean example off the top of my head. Go me. Okay. So yeah, it can.
On our homework that we have.
Most likely.
You should have divided it by 2.7.
So here is an image of the steps that you would take and works it out. Okay? As it works out. So the main concepts are addition and subtraction. Line up the decimals. Multiplication and division are different things. Multiplication, you forget about the decimals. When you're at the end, after you find your product, you count how many decimal places go back in. With division, the divisor cannot have any decimals. Those are the 4 things for today. Okay? And because we have time, I think I can get those integers printed up for you, okay? Would that be good? All right.